The wrong engine oil doesn't just cause extra wear. It triggers low-speed pre-ignition, vaporizes onto your intake valves, and turns your piston rings into charcoal. Most people pick their oil based on price or a TV ad. In a modern turbocharged or GDI engine, that is a $10,000 mistake. Today I'm breaking down 7 oils I would never put in my car, and 3 I actually trust. No brand loyalty, just the chemistry. Let's get into it. Before we get to the blacklist, I want to give you one framework that will change how you read an oil label forever. When you look at a bottle of engine oil, the 2 most important things on that bottle are not the brand name and they are not the price. They are the API certification and the base oil category. The API certification, that's the American Petroleum Institute, is your first line of defense. Right now, the current top standard is called API SP. Below that is API SN+, SN, SM, and older. Every step down that ladder represents a formula that is less equipped to handle the demands of a modern engine, especially around LSPI protection and oxidation resistance. The base oil category is where the real story lives. Base oils are classified from Group 1 all the way to Group 5. Most conventional oils use Group 1 or 2. Most full synthetics use Group 3 or above. The higher the group, the more refined and thermally stable the base stock. And that stability, that is the difference between clean engine internals and carbon-caked disaster. Keep those 2 concepts in your head. They're going to explain everything that follows. Let's get into the blacklist. Number 1. The gas station house brand. Walk into any major gas station or big box discount store and you'll find their own private label oil on the bottom shelf. Usually something like Superdrive or Motor Guard or some generic name with a racing stripe on the label. Here's the problem. These oils are almost universally formulated to an older API standard, SN, or sometimes even older. They exist in a regulatory gap where they can still legally be sold, even though they were designed before engine technology moved on. And the critical issue here involves calcium. Modern engine oil uses calcium-based detergent additives to clean your engine. But when calcium levels get too high, and in these older formulations they do, you create a chemical environment in your cylinder that is extremely prone to low-speed pre-ignition. LSPI is when the air-fuel mixture ignites before the spark plug fires. The pressure wave that creates can, and does, punch a hole through a piston, literally. A hole through the metal. The API SP standard was specifically engineered to limit calcium levels and reduce LSPI risk. If your oil doesn't carry that certification, your engine is gambling every single time it starts. Number 2. Non-Detergent SAE 30, the dollar store trap. This one still surprises people when they see it on shelves. Plain, single-grade, non-detergent SAE 30 motor oil. And yes, it is still being sold in 2024. Not because it's useful for modern vehicles, but because it has a legitimate application in very old engines, lawnmowers, and air compressors. The key phrase there is non-detergent. Modern engines rely on detergent additives in the oil to continuously scrub varnish, sludge, and carbon deposits off internal surfaces as the engine runs. Without those detergents, deposits accumulate. And one of the first victims is your variable valve timing system, the VVT solenoids that control when your valves open and close. Those solenoids have passageways measured in fractions of a millimeter. A small amount of sludge is all it takes to seize them completely. VVT solenoid replacement, $300 to $700. And that's if it's just the solenoid and not the actuator or the cam phaser behind it. Non-detergent oil in a modern engine is not a budget decision. It is an expensive mistake dressed up in cheap packaging. Number 3. Racing oils in a street car. This one gets car enthusiasts in trouble because it sounds logical on the surface. Race engines need the best protection. I want the best protection. Therefore, racing oil must be better for my car. It isn't. And the reason comes down to zinc. Specifically, a compound called ZDDP, zinc dialkyl dithiophosphate. Racing oils are loaded with it because it provides exceptional wear protection for flat tappet camshafts and high-load bearings under extreme race conditions. But zinc is a catalytic converter poison. When oil containing high levels of ZDDP burns or evaporates, even in tiny amounts, it coats the precious metals inside your catalytic converter and slowly destroys their ability to process exhaust gases. Over time, your catalytic converter fails. And a catalytic converter replacement on a modern vehicle runs anywhere from $800 to over $2,000. Racing oil is engineered for engines without catalytic converters, running on race fuel, being rebuilt frequently. It is not engineered for your daily commute. Number 4. Bulk mystery oil from fast lube chains. This one is less about a product category and more about a supply chain reality that most people never think about. When a discount oil change shop advertises a full synthetic oil change for $19, ask yourself a simple question: where is that oil coming from? The answer, in many cases, is that these shops purchase bulk oil, sometimes thousands of gallons at a time, from the lowest cost supplier available that week. The brand name on the receipt may say one thing. What goes in your engine may be something else entirely. And here's the technical concern: NOAC volatility. NOAC volatility is the standardized test for how much an oil evaporates at high temperature. A high NOAC number means the oil vaporizes readily inside your engine. And that vapor doesn't disappear. It travels through your PCV system, gets ingested through your intake, and deposits itself as a carbon film on the backs of your intake valves. In a port-injected engine, the fuel spray washes those valves clean. In a GDI engine, there is no fuel spray touching those valves. The carbon builds up, restricts airflow, causes misfires, and eventually requires a procedure called an intake valve cleaning, which runs $300 to $600 and could have been completely avoided. Number 5. Counterfeit premium oils from online marketplaces. This one is growing, and it is dangerous in a way that's very hard to detect. Third-party sellers on major online retail platforms have been caught, repeatedly and on a documented basis, selling counterfeit versions of premium oil brands. The bottles look identical, the labels look identical, the seals look legitimate. But independent lab testing on seized counterfeit bottles has found base oil with virtually zero additive content. Recycled, used, or heavily degraded base stock with nothing in it to protect your engine. The tell is almost always price. If a 5-quart jug of a premium brand is being sold at 40% below what every legitimate retailer charges, that is not a deal. That is bait. Buy engine oil from brand-authorized sellers, reputable auto parts stores, or directly from the manufacturer's website. The few dollars you save on a counterfeit jug is not worth the engine it costs you. Number 6. High-mileage oils with stop-leak additives. High-mileage oils occupy a legitimate and useful category. If your engine has over 75,000 miles and is starting to show minor seepage at gaskets or seals, the seal conditioning additives in a quality, high-mileage oil can genuinely help. The mistake is using these oils before there's a problem. Those stop-leak and seal conditioning compounds work by swelling rubber seals, slightly expanding them to restore a tighter fit. If your seals are healthy, you're introducing a chemical that is actively softening and swelling rubber that didn't need to be swelled. Over time, that unnecessary swelling weakens the seal material, making it more brittle and more prone to actual failure. The irony is real. Using stop-leak oil preventatively in a healthy engine can create the exact leaks it was designed to fix. Match the product to the problem. If there's no leak, use a standard full synthetic. Save the high-mileage formula for when it's actually warranted. Number 7. Conventional oil in a modern turbocharged engine. And here's the big one. Conventional motor oil, the kind refined directly from crude oil without the additional processing that creates a true synthetic, has been the standard for most of automotive history. And in a naturally aspirated engine running moderate temperatures, it does an acceptable job. But put that oil in a turbocharged engine, and you are asking it to do something it was never designed to do. A modern turbocharger spins at up to 200,000 rotations per minute. The bearing inside that turbocharger is lubricated entirely by the engine oil circulating through it. At those speeds, the oil temperature at the turbo bearing can exceed 300 degrees Fahrenheit, sometimes significantly higher. Conventional oil at that temperature doesn't just lose viscosity. It undergoes thermal degradation. It breaks down chemically, leaving behind carbonaceous deposits, what engineers call coke, on the bearing housing, the oil feed passages, and the turbine shaft. Once those deposits form, the oil can no longer reach the bearing efficiently. Lubrication starves, the bearing fails, and a turbocharger replacement is not a quick, cheap repair. Full synthetic oil, with its higher group base stock and superior thermal stability, handles these temperatures without breaking down. In a turbocharged engine, synthetic oil is not a premium upgrade. It is the minimum viable product. Now let's talk about the 3 oils that have earned a place in my garage and why, based on the same chemistry logic we just applied to the blacklist. Number 1. Pennzoil Ultra Platinum. Pennzoil Ultra Platinum earns its place on this list because of something genuinely unique about where its base oil comes from. Most synthetic motor oils, even high-quality ones, start with crude oil. The crude is refined and processed until you get a Group 3 base stock that qualifies as a synthetic under API definitions. Pennzoil Ultra Platinum uses a different process entirely. Through their Pure Plus technology, they convert natural gas, not crude oil, directly into a base oil. Natural gas is a far simpler hydrocarbon feedstock than crude oil, which means the resulting base stock contains almost none of the sulfur compounds, wax, and contaminants that you have to process out of crude. The result is one of the lowest NOAC volatility scores in its category. Less evaporation, less oil vapor entering your intake, cleaner intake valves. In a GDI engine, that is not a minor benefit. That is meaningful, measurable protection against one of the most common failure modes on the road today. Number 2. Amsoil Signature Series. If you are in the engineering community, Amsoil Signature Series is the oil that gets cited most often when the conversation turns to shear stability. Shear stability refers to an oil's ability to maintain its viscosity under mechanical stress. When oil is physically sheared between moving metal surfaces at high loads, in a transmission, around a crankshaft, in a heavily loaded engine, lesser oils thin out. Their viscosity rating becomes a fiction. The protection they advertise on the label disappears when you actually need it most. Amsoil Signature Series is formulated to hold its viscosity rating through extended intervals and extreme conditions in a way that independent comparative testing consistently validates. It is the benchmark that other premium oils are measured against. If your priority is maximum metal-to-metal wear protection, particularly in a performance-oriented or heavily used engine, this is the reference point. Number 3. Mobil 1 Extended Performance. Mobil 1's place on this list comes down to one thing that money simply cannot fake: original equipment manufacturer relationships. Mobil 1 works directly with companies like Porsche, Corvette, and AMG during engine development. Not after the engine is designed, during it. That means their formulation team has access to data about thermal cycles, fuel dilution patterns, and wear mechanisms that no aftermarket oil manufacturer can replicate from the outside. Their extended performance line specifically is built to handle fuel dilution, the phenomenon in GDI engines where unburned fuel washes into the crankcase and dilutes the oil. Fuel dilution reduces viscosity, strips additive protection, and accelerates wear. Mobil 1 Extended Performance's additive package is one of the most robust on the market for maintaining protection even when dilution occurs. It is not a coincidence that Mobil 1 is factory-filled in some of the most demanding production engines in the world. That is a result of thousands of hours of co-development testing. Your engine doesn't care about the label. It only experiences the chemistry you chose. One rule to remember: look for API-SP certification. If your engine is turbocharged or GDI, full synthetic with low NOAC volatility isn't optional. It's the minimum. And if a deal looks too good to be true, it is. Drop your car and your current oil in the comments. I read them all.